Today's presentation will be an introduction to device-level ring Ethernet protocol. Before we begin, I'd like to introduce myself. My name is Matt Tellier. I am the Motion Control Product Manager for AMCI. I have been here for the past 19 years, and I have worked in several capacities, which include sales engineering, application support, product development, and currently Motion Control Product Manager. Having worked extensively with position sensing technology and specialty I/O, and my background is I have a BS in electrical engineering from the University of Connecticut. Our agenda today, we will begin by discussing the three basic network topologies: the star network, the linear network, and the ring network. And then from there, we'll move to introducing what exactly is DLR, or device level ring. And after a brief introduction of what that is, we will discuss how does it actually work, what happens during normal operation and when there's a break in the network. And then there'll be a screen which discusses the different products that are available for DLR. And then we will close with a question and answer session. And for those of you online today, we'll be using the chat window for Q&A as I have everybody muted. So if you have any questions, please enter them in the chat window. To start with, we're going to go over the basics of each of those three networks, the first being a star topology. In star topology, every node is connected to a central node, and that central node is called a hub or a switch being the more common today. This central node provides a common connection point for all of the nodes. In an industrial network, you typically would have a PLC and then all of your other peripheral products communicating to that PLC through that industrial switch. The advantages of that type of network are that the devices communicate through that switch or hub. And as you can see here, the PLC would send messages to all of the peripheral devices, and if need be, can also receive messages from those peripheral devices. It's easy to add a node, so if my switch has any open ports, to add a node, I simply plug an Ethernet connector from the additional device into my switch, and I can now connect and communicate through the switch to that device. And if a node fails, for example, one of the sensors or say a cable, one of the devices communicating to the host controller fails, the rest of the network stays up and running. So it can be a very robust network. Some of the disadvantages that occur with a star topology is it does require more cabling because I have to run all of my devices to a central point. That central point may actually be further away than the host controller, so it can add some cost through extra cabling. And the number of nodes is limited by the switch. So if I have an 8-port switch, I'm limited to communicating to 8 devices or having 8 devices on there. If I need to add more devices, then I need to add a switch, which means switches are an added cost. And if for some reason the switch fails, the entire network is compromised. The second network topology we're going to look at is a linear network. With a linear network, we have a collection of devices that are daisy-chained together. Each device along the network has its own embedded switch. This device's embedded switch allows implementation of the linear topology at the device level, meaning there's no external device to connect to. Everything is connected from device to device. As I said, there is no external switch. In this topology, the host controller would send messages out through its main port, and that message would go to a device. If that device is meant to consume it, it consumes it. Otherwise, it passes it along the network tree. With these devices, one of the advantages is that the switch is embedded in each device, which helps to eliminate the need for an external switch. It also simplifies installation. As long as the last device on the linear network has an embedded switch, I can add another device just by simply connecting to that last device on the network. which means it's very easy to add a node. And unlike if we're using, for example, in a star topology, a managed switch, it requires some sort of special configuration software. With a linear network, there is no special configuration software required. Some of the disadvantages are that any break in the cable disconnects devices downstream. So if, say, for example, the first device has a failure, every other network product is lost, which obviously is a disadvantage. And troubleshooting can be difficult because there is only one connection point to the host controller. If we have multiple failures, we will only be able to detect the first failure. Which leads us to a ring topology. With a ring topology, it's set up in a circular fashion where data travels around the ring in one direction, and each device on the ring acts as a repeater. Each device incorporates a receiver for the incoming signal and a transmitter to send data on to the next device in the ring. The advantages are, just like with a linear network, each device contains a switch. But because it is in a ring mode, which allows the data to travel in both directions, it's more resilient to single point failure. And that's resiliency and the ability to communicate out of both ports allows for fast recovery when a fault occurs. Once the controller is set up in the proper manner for fault detection, it can then switch over from a ring network to a traditional linear network. Some of the disadvantages are it's more expensive than a linear network, obviously, because each device is required to have both ports, including the controller and the last device in the network. And we must have a method to keep track of the packets as they move along the network so they won't just keep circulating forever. Which leads us on to a more defined method for communicating on a ring type network, which is the device level ring, DLR, which is what we're discussing today. DLR is an ODVA defined method for managing communication on an Ethernet ring topology. And being ODVA, that Ethernet protocol is Ethernet IP. What the DLR defines is the method to prevent messages from circulating forever. That's part of the protocol. It defines the supervisor and ring nodes. The supervisor being basically the master controller, and then most of your industrial networks would be some sort of PLC controller. And the ring nodes, which are the other devices or auxiliary devices that are sitting on that ring network. It defines how to detect a break in the network and how to reconfigure it into a linear network. And last, it defines how to detect the network is repaired and how to reestablish the network into a ring mode. So exactly how does it work? Well, first, one of the nodes is defined as the supervisor, and the supervisor manages the network traffic. In this case, as I said, oftentimes this will be a PLC of some variety. The supervisor sends out a message from both ports. That message is called a beacon frame. This message, its only intent is to monitor ring's integrity, and it's sent out of both ports. There are two ports in the supervisor, one called the primary port and one called the secondary port. Data packets are sent out through the primary port only, and the secondary port is blocked from sending data. This way, we don't have a situation where data is being sent in both directions, creating network traffic. A ring node receives the message. If the ring node is the intended recipient, it consumes the message, otherwise it forwards it on. A ring node can also send messages. These messages are only received on the primary port of the supervisor, as the secondary port is blocked from receiving data packets. So what exactly happens when the ring breaks? In this case here, we have a break between what is a distributed I/O point and a sensor. So when the ring breaks, the beacon frame is sent out through the primary port, but is not received back at the secondary port. Also, there's a message sent back from the device where the break has occurred. It's sending a message back to the supervisor telling it exactly where the break in the network has occurred. At this point, the supervisor switches over from sending data in a ring mode and sends it out in basically two basic linear networks, one out of the primary port and one out of the secondary port. At this point, our technician has been notified that there's been a failure and the repairs made to the network. At this time, and throughout the entire time that there's a network failure, the primary port is sending out beacon frames to monitor when the ring has been reestablished. Once it receives the beacon frame back at the secondary port, it knows that the ring has been reestablished and starts to send messages back out to a ring mode fashion, only through the primary port and closing off the secondary port from sending messages. We have a question here. The question is, can any device be used on a DLR network if the PLC is DLR equipped, or does the device also have to be DLR enabled? Well, it does, but there are products available that you can take a device, say a single port Ethernet device, and basically acts as a tap, which allows you to add that device onto a DLR network. So if you happen to have a DLR network and want to add a device which has a single Ethernet port, you can do so with those types of products. Which leads us to our next slide, which is what products are available for DLR. Because it's an Ethernet IP protocol, obviously you would expect it to be populated with quite a few products from Rockwell Automation and its partners, and this would be true. For PLCs, you're looking at ControlLogix and CompactLogix type PLCs having DLR available.
For stepper motion, there's AMCI's SD series of integrated drive and controllers, or SMD series of integrated drives, motors, and controls.
There's both servo drives and AC power drives now have DLR available. And as I spoke to, there are adapters available from Rockwell Automation, which allow you to take single port Ethernet devices and add them to a DLR network. And there is also remote I/O with embedded DLR for those types of applications where you want to have your remote I/O but also take advantage of the DLR network. That concludes our brief presentation today.